at time t. Okay, you can have a function, okay, c, that is kind of representing the cost of producing x units of the function actually. Okay, x units of some product. So these are functions given to you. So imagine you have been given a formula of a function. Okay, so T equal to T is really, say for example, T square plus 2. Okay, so the temperature is varying over the time, say for example this formula. The velocity of the function is say sine t. Okay, so it's like oscillating, going up and down, and say cost of the function is say 2x square plus 3x, something like this. So imagine all of these functions are defined on some interval, say 0 to 1. Say this is defined on 0 to 2, this is defined on say 1 to 5, so on and so forth. So on this interval, this function is going to take a lot of values. For each value of t in this interval, there is a value of the temperature. For each value of the t in this interval, there is a value of velocity. For each value of the x in this interval, there is a value of cost actually. So in other words, you have been given a function that has some meaning. Okay? Function y equal to f of x. Okay, that has been defined as that has some physical meaning. Could be temperature, could be velocity, could be cost, it could be concentration, it could be performance of your algorithm, it could be anything actually. Okay, it could be anything. I'm interested in, okay, this y, this curve is taking a lot of values corresponding to y. Okay, so it takes a lot of values. What is the average of all these values? What is the average of all these values actually? This is what that I would like to compute. Okay? So how you can compute it? How do you compute the average value in particular? So if you have been given, for example, some values, okay, so imagine, so x1, x2, x10 is some data. These are some numbers and you need to compute their average. So how are you going to compute it? You're going to sum them up and divide by the total number of objects. I want to do something precisely same here. So let's first split, what do you call, this interval a to b into n parts. Okay, n parts. So this a is x0, b is xn, this is x1, x2, this is some general interval xi plus 1, okay, and this is the second last point, xn minus 1, okay, so this is xn minus 1, this point is xn minus 1, okay, and on each interval, okay, on each interval, imagine that this interval is really small actually, okay, it's really small. On each interval, for example, if you say what is the values that this function is taking, so these are the set of values that on this interval the function is taking, these values, okay, these values. If you see, these values are not too much different actually, okay. So you can say that, okay, so for example, the lowest value is this and highest value is this. The lowest value is this and the highest value is this. You can see that, the value of the function here and the value of the function here are not too much, different actually. They are really close to each other. Okay? They are really close to each other. So let's say that on each interval I take, for example, the value of the function at left end point. I can take at any end point, I can take right end point, I can take middle point, I can take any point actually. So on each subinterval, say on x0 to x1, this interval, function takes a fixed value f of x1 actually. It can take some other value than f of x1, but they are all going to be really close to f of x1. On interval x1 to x2, say it takes value f of x2. Okay? And so on and so forth. xn minus 1 to xn, say it takes value f of xn. Okay? It takes value f of xn. Let's assume that all of these intervals have same length actually. Okay? They have a same width. So delta x is really xi plus 1 minus xi. So it is x1 minus x0, x2 minus x1, x3 minus x2. So all of these intervals have the same value. Okay? Now I want to compute the average of these values. So what would be the average of these n values? So the average of these n values is going to be f of x1 plus f of x2 plus so on and so forth, f of xn divided by n actually. Okay, divided by n. Okay, divided by n. By the way, what is the relationship between n and delta x? In other words, how did I computed the value of the delta x using this n and the length of the interval AB? So in other words, I have an interval from A to B. I want to split it into n parts, n subinterval. What should be the length of each subinterval? So what we're going to do, we're going to say that the length of each subinterval is delta x, and it is going to be take the length b minus a of the interval and split it into the n parts. So the delta x is b minus a upon n. So this means n will become what? From this formula I can say n will become b minus a over delta x. So if I wish, okay, if I wish, on the place of n, I can substitute b minus a over delta x. Okay? So this is the major fraction. This delta x will be multiplied with this sum. So when you're going to simplify this, you're going to get f of x1 plus f of x2 plus so on and so forth, f of xn multiplied by delta x and everything divided by b minus a. Okay? B minus a. And this is what? By the way, this is what? This is the average value of f. So let's call it f average. The average value of f actually. Maybe approximately average value of f. Because, these are discrete approximations. Okay? So what can I do? So when you see this, do you remember something? I can write this as 1 over b minus a and sum that goes from I equal to 1 to n, f of xi times delta x. What will happen if I take the limit n goes to infinity? In other words, I divide this interval into really tiny subinterval. I increase the number of subinterval. Then I'm going to get the exact average value. But this exact average value is going to be now, when you compute this 1 over b minus a is going to stay 1 over b minus a. This sum is a Riemann sum. This will become what you call an integral. A to b f of x dx. So you have this beautiful formula coming out as the average value of a function on a given interval. Okay? So if you want to compute the average value of a given function on a given interval, just integrate that function over the interval. Okay? It's like sum up all the values of f over this interval and divide by the length of the interval. So this is going to give you the average value of the function actually. Okay? This is going to give you the average value of the function. So imagine, you have this example, imagine temperature on a day variates with this formula, you know, T of t equal to 1 plus t square, where the t is the instants between say 2 hours, 0 to 2. So the 0 to 2 is representing 120 minutes actually, okay, or 2 hours. Then what is the average value of the temperature in these 2 hours? So in order to compute the average value of the temperature in these 2 hours, you need to integrate the average, the temperature, okay, from 0 to 2 and divide it by the length of the interval 2 minus 0. Okay? So this is going to be 1/2 0 to 2 t of t is 1 plus t square dt. So if you simplify this integral, you're gonna get what? You're gonna get something interesting. So you're gonna get 1/2 of t plus t cube upon 3, 0 to 1. Okay? So if you substitute these values, you're going to get 2 actually. Okay? So if the temperature is measured in centigrades, so if this is measured in centigrades, then average temperature on, you know, this interval is 2 centigrade actually. So this beautiful formula gives you the average of the function. Okay? By the way, when you have to practically solve the problems, you don't have to drive it, you just have to use the formula. I'm making the derivation for you. I'm justifying that why this formula is really the formula for the average. Why the all previous formula, the length of the curve, the volume of the, you know, solid of revolution, why all these formulas make sense. You don't have to drive those formulas, you just have to, you know, apply them in order to solve the problem. So these are some of the, you know, simple applications of integration. We're gonna discuss more